information. I have not. Just waiting. This is a rather classical satellite, something that will carry radio. What is not classical in the satellite is that it will be on the 20 degrees only inclination orbit. So this is the daily track of the satellite, which will give up to 5 to 6 overpasses per day in the tropical belt. So combining this information with other satellites will give unprecedented high precision temporal survey of the storms. On the satellite will be a shortwave and longwave radiative flux measurements, a humidity sounder at 183 gigahertz for this measurement, and a microwave imager with different channels from 18 to 157 gigahertz. This is a new channel, and we think that this channel can provide first high resolution measurement, less than 10 kilometers, and also information on what we call small ice. So it will be interesting to combine in situ measurement with this observation to be sure about that's what we observe. And about 1/3 to 1/4 of the flights will be reserved to flights under the track of the satellites, like we did during this the AMA experiment 3 years ago. Well, sure, numerical modeling will also be part here for research and operational purposes, like I've shown you before. And also we will trying to adapt targeted observation techniques which are developed now in Météo France for mid-latitude cyclone in the Atlantic and Mediterranean to this tropical environment. And finally, should we have conducted the experiment this year in January and February, then we would have observed interesting thing. Well, probably not very exciting or not very intense storm, but interesting situations. No, not yet. 9 is a tropical perturbation here, which was very short-lived. 10 here is a tropical depression, which was very long-lived. Fami is a tropical storm that makes landfall on Madagascar, and Gelan is the most intense tropical cyclone this year, but with a very short duration, and which has an unusual situation, the reverse of what is. And what you can see here on this Meteosat water vapor channel images, and that this year we had very strong interaction with dry air, represented by this black region, coming from the mid-latitude. And this year, the mid-latitude in the Southern Ocean were very active and sent a lot of dry air with upper-level perturbation, which interacted with the tropical storms. Would have been interesting thing to look at. No. No. Okay. Thank you.
Okay, question or two? Yes,
Two questions. First is short, is the limitation of the ceiling flight height of 35,000 feet high enough for this to carry out the targeted observation. And the second is I'm not familiar with the weather pattern in the West Indian Ocean. So what is the main target weather systems that may affect the tropical cyclone in that area?
Well, the first thing concerning the sealing of the aircraft, we have tried doing the AMA experiment in 2006 in Africa to reach the 38,000 feet level, but it takes hours to get there. So it's relatively easy to get to 35,000 feet. So that's what can be done with this aircraft. So we'll live with that. I would like to go higher, but it's not possible. So, second point is that the interesting situation in the Southwest Indian Ocean is that nothing is relatively well known about cyclogenesis. Some studies have shown that mixed force big gravity wave plays a major role. There are no easterly waves there in this region. So it's complicated. And the other thing is that the ocean there is relatively particular because the mixed layer is very shallow in this region. It's less than 50 meters, which means that it reacts very rapidly. Convection creates rapidly, but once convection creates and we want to have a gas front at the surface, then the surface can cool rapidly too. So it's a very reactive environment. And the third point is that we have a relatively strong interaction with the mid-altitude circulation. A lot of structures, I call them structures because it's not yet well, upper level loads or things like that come from the mid-altitude and can interact, especially in the Mozambique channel. So, I mean, there's a lot of things to learn about the physical processes, and we think that with what we have now, it's not possible to go into detail because observations are not enough, so we plan to have this specialized measurement here.
Okay, one more question? Yes, Russ.
Just another clarifications on the Falcon. You said 5 hours? I thought it was even more limited than 5 hours.
Well, you know, as pilots, it's always difficult to know how long an aircraft can fly because, well, technically it can fly 6 hours, but they want to save 1 hour, and if they are not confident in the aircraft, in the airport, they want to save also 1 hour. So it's a discussion, it's an ongoing discussion. I know we can fly 5 hours, but who knows?
Any ocean surface temperature measurements on board the Falcon?
No. No, unfortunately, it was not possible to combine this experiment with the oceanic program, which has been cancelled. But I know that in 2012 there is an ongoing experiment by US, Japan, and India in the Indian Ocean. So should the experiment shift from 1 year, then we could combine, but it's not yet on discussion.
Okay, thanks again, Frank.